Hello everyone, in this video we will be solving problem 211, design, add and search words data structure. The problem statement is we need to design a data structure that supports adding new words and finding if the string matches any previously added words. We will be having a constructor, a method for adding the words called addWord, and a method called search which accepts a string parameter and returns true or false.
If we see a dot in the input search string, it can be matched to any character in the string that we have previously saved to the database. In this example, we are given these three words that is passed to the addWord method, which needs to be saved to the database.
And the remaining four are the actual search instructions or search methods executed with this as an input. So if you look at the first three input, we are adding bad, dad and mad. And now for the search, when we are getting bad as an input, because we do not have any text that matches that search word, so we will be returning false. Now if you look at the next one, which is bad as an input, we do have a word called bad, so we will be returning true. After that, we have a dot and AD. If we have a dot, we need to ignore that character. So because it is started with a dot, we will ignore the first character of all the words and look at the next one. We have A, so all of these words qualify, and then we have D, again all of these three qualify. So hence we are returning true. And even in the last one, we have B dot dot. So between bad, dad and mad, we have one word starting with B, and because the remaining two are dots which we have to ignore, so we will ignore those, and because we found a word, we will return true. One important constraint over here is we need to return true only if we are able to find the complete word. For example, let's say my input is, and if my search criteria is P dot dot, even though this word sort of qualifies in this search parameter, but still it is not enough because we are looking for a word with 3 characters only. We have a word with 5 characters. So we need to return false in that scenario. Now that we have talked about the problem and a couple of scenarios, let's switch to whiteboard and talk about what is the best data structure that we can use to solve this problem. Normally, the simplest solution to such problems is brute force, where we are recording all the inputs in an array. When the search method is invoked, we will iterate through all the values in the array, compare the search word with each of the word, and find out if there is any match. If we find a match at that moment, we will stop the iteration and return true. And if not, then we will return false. Even though this solution is the simplest solution, it is not a scalable one, because if we have, let's say, 5,000 words and the character length is at least 10, then we are running the loop at least 50,000 times, because we have to go through each and every character for each word to make sure that we are checking for each valid case. Hence, the time complexity will be exponentially large. So this is definitely not going to give us an efficient solution. Now let's talk about a different data structure or an approach to solve this. Given the problem statement and the cases that we have to cover for testing, I feel like a search tree is going to be the best suited one. Specifically, I am talking about the prefix search tree. If you haven't heard about this algorithm or this data structure, I'll briefly talk about it in this video. The way this search tree works is, for each word, let's say we have a word A, B, C. So for each word, we will have a node. Let's say we have a node for A. For the next letter in the word after A, we will have a separate child node. So I will have B here. Naturally, this A is going to have a root, which is going to be common for all the letters. And after B, we have C, and I will add C here. Now similarly, we will do the same iteration for the next word, which is dad. Because we haven't covered D over here, I will create a new node, and then after D, we don't have any other nodes inside it, so I'll add a new altogether. If I look at mad, we will have the same scenario. Let's say I want to add another word, day. So now if I want to add it into the same data structure, from root, I will check if the first character exists. Yes, D exists. So I will use that. So I will go to D. Now I need to check the next character. So after D, I have A. So I will again check if I have a node with the value A. Yes, I do. So I will go there. Now inside A, the next character that I'm looking for is Y. Do I have a Y? No, I do not. So I will create a new one. One important part over here is the way to identify if we are done with the word or not. So at each point when I was iterating for day, D is not the last character of the word, A is not, but Y is. So whenever I am at Y, we will highlight it with a different color, and when we are coding it, we'll probably add a new property. So whenever we are at the end, I'll just highlight it with green just to make sure it's distinguishable. I'm hoping that you are able to understand how this prefix search tree is going to be designed and how it fits into the first part of our problem, where we have to add all the inputs that we are getting whenever add method is called. Now the next part is to search. I just randomly chose 4 words we will be using for testing. Let's start with that. We will start iteration with one character at a time. So I will check underneath root if I have a character D. I do have a character D, so I will go there, and inside it I will check for the next character, which is A. Do I have A inside it? Yes, I do. The next one I'm looking for is D. Inside A, do I have D? Yes, I do. So with my search pattern, I am at the end of the word. So my requirement is to make sure that this character D is also the last character of the word. In other words, I need to have a word that ends with D. I could have 2 words in my input. I can have one as dad and one as daddy, which are both acceptable. I need to make sure that I have a word called dad. And because when we were entering the data, we made sure that we highlighted this node with the green color saying that this is the end of the word. This tells me that I have a word that matches my search criteria or search pattern. So I will return true. Now let's look at the next example. It's May. So starting from the root, I'm looking for M. Do I have a M? Yes, I do. So I will go to the M node. After that, I'm looking for A. So do I have a A node? Yes, I do. So I will go to A. After that, I'm looking for Y. Do I have a Y node here? I don't. I will return false. The next part is interesting. We have D dot and dot. So when we check for D, I will check from the root. I do have a D, so I'm at this D node. The next is a dot. So when we say it is a dot, we don't care about what is the character. We will take everything. So underneath D, we only have one character A. So we will take A as the next iteration. If I had B over here, I would have taken DA and DB both. After A, the third character in my search pattern is a dot again. So from A, I will look at all the children or all the nodes underneath it and add that to my condition, or that qualifies to be my search pattern. So I will take Y, I will take D. So now I have DAY, DAD. Now I have to check if the words end at Y or D because I'm looking for a word with only 3 characters. And over here, both of the words matches that pattern, so my return is going to be true. The next scenario, which is A dot B. So when I check with A, underneath my root, I have an A. So I will come to this node. After that, I have a dot. So I will take everything. So I'll go with the B first. And after B, I am looking for another node with a B in it. Because underneath this B node, I don't have any other B nodes, I will return false. I hope you were able to understand this explanation. Let me show you how we can build this data structure using C#.
The C# implementation, we have the box dictionary, and I have created this custom class as my data structure to hold the information. This custom tree class contains two properties. One is the children, which is a dictionary of character and custom tree, and I have this property called isEnd, which will help me determine if the character that we are looking at is at the end of the word or not. And the constructor is going to initialize this children variable and create a new instance of it. I have this property called root, which is going to hold all the nodes that we talked about. So starting from the root, if we have like dad, so it will have the first layer as D and then A and then D. In the constructor, I am initializing this root variable. Next, we have this method add word where we get the word. So whenever this method is called, I have starting this while loop, which will run through all the characters in the word. And I have created this temporary variable which will hold the instance of the custom tree at each layer. So inside the while loop, I'm getting the character, and then I'm checking if the character already exists in this temp custom tree. If it exists, it means there's already a word that was created before with that character. So I do not need to create a new node altogether. I can use that. So in that case, I am not going to be going inside this condition. And if that node does not exist, so I'm creating a new node inside this children. So I'm passing the character and then a new instance of custom tree. As we are incrementing the pointer, we need to now look at the next layer of nodes. Hence, we are replacing the value of temp by the children. After this while loop is done, we will have all of the characters inserted into the custom tree, and this temp variable will still be pointing to the last value or last character that we inserted, which we can safely say is the end of the word. Hence, I am marking the isEnd property to true. The next important method is this search, where we get this word as an input. So here I have created this list of custom tree called trees, which will hold all of the custom trees that we need to search for. I'll talk about why I'm using a list instead of a single instance in a moment. So just like before, I have this while loop which will run until the end of the word. I am extracting the character from the word based on the index, and then I have this temporary variable that will hold the values of all the next custom trees that are qualified or that matches to the search pattern, and we need to continue searching forward. Then I start this for each loop to iterate through all of the trees that are qualified so far. So when this is running for the first time, the root is the only tree that is qualified. Hence we will have only one. But in case we have a search parameter as a dot, we can have multiple children that are qualified. Hence I am using this list of trees instead of just one. So inside this for each loop, I am running it for all the nodes and checking if any of the children contains the key of this character. If it does, then I'm adding that children to the temporary variable so that we can continue this searching for the next hierarchy or the next character once we increment the pointer. If the character is a dot, then I'm doing a temp dot add range and adding all of the children to this temporary variable, because we have to search through all of the words and not just one particular node. Once the for each loop is complete, I am replacing the value of trees with this temp variable that we built just now based on this for each loop and the search criteria, and after that I am incrementing my pointer. So this while loop will run until we are at the end of the word and we have gone through all of the characters. After the for each loop is done, I am checking if this trees variable have any entries with isEnd property set to true, because we are looking for a word that actually ends at the right like alphabet and not keep on continuing forward. If we find any such value, this any method will return true or else it will return false. I hope you were able to understand my explanation and the source code that I just walked you through. If you have any questions or concerns, feel free to reach out to me via comments. This source code is available on my GitHub repository. I'll be adding the link in the description below. Feel free to check that out, and I will see you in the next one. Happy coding!